Cool. So, every one of you have heard about generative AI. Anyone in the room has not heard about this word, generative AI? Everyone knows about generative AI, right? You don't know about generative AI. So I want to talk about. You know about AI? But you have heard the word. Yeah, yes. My question is that any one of you have not heard about the word generative AI in the room? You have not heard. You have not heard. Is it like seriously or you're okay? Okay, so I just wanted to understand the audience. Uh, Artificial intelligence, everyone has heard. So generative AI, today I'm going to talk not I'm going to talk more about what is generative AI, but I'm going to talk why is it so important. Is it a really a hype? Because right now I'm asking this question because generative AI is a hype of this year. And many companies are wanting to use AI, and that is not actually AI, it is generative AI. They just are not able to understand the difference between generative AI and the normal AI that is there, which we want to talk about. So a little bit, we are going to just discuss these topics. What is AI, generative AI, some of the use cases, how to use it, and the application development part. Why application development? Because this is something that is very important in making generative AI a big hype that is there. So a little bit about myself. So before coming to Dubai, I was working in Accenture Consulting for more than 7.5 years, and I got an opportunity to come to Nakheel for a project. And then we really liked Dubai, and we made it our home. I was working in Majid Al Futtaim, and 1 year, 3 months back, I left that and I started my passion, my company, Decoding Data Science, which is a consulting, an academy, and this community is also a part of that initiative. And in the journey, we have helped a lot of people, individuals, companies to get into the AI journey. And today, we are just going to quickly talk about generative AI and the buzz around it. Why is there so much buzz? Why are people talking so much about it? And now coming to generative AI, the most simplest definition of a generative AI is it is designed to generate a new content. It can be a text, it can be voice, it can be video. So all that is generative AI. So whenever the word generative comes, it just means that you are able to generate something out of the model, and that is why it is so important. And people are using it because before in the AI, traditional AI, you needed a lot of historical data to build models and deploy it, and many non-technical people do not use it. But now generative AI, you run some models, you get a text, you get a audio, video that can be pre-used for your work and business, and that is why many people are using it. Three things are very important for generative AI, and the first one is the prompt engineering. Is my voice coming clear? Is it breaking? It's breaking or it's fine? It's fine. Cool. So now coming the first step is the input, the prompt engineering, and this is why generative AI becomes so special, right? You as a user, you have control when using this AI. In traditional AI, the historical data is being trained by machine learning engineers and the output comes in. But in generative AI, the system is designed in such a way that the user can give a prompt and they can get an output. So that's why prompt engineering is very much used word, because the way you give prompt, if you are architecting it properly, then your output is going to get better, and that is why generative AI is very much in use. So the input goes to an engine. The AI engine converts the prompt. So the AI engine can be any open AI, Llama 2, anything that is there. It can be Bard, Bing, whatever it is. That is not important for us. I think 1 second. And the last part is output as desired. And why you mention desired? Because you can change it. If you don't like the output, you can go back, you can ask the prompt to make it better. And you might, all of us who are using ChatGPT for a long time, you will see the behavior improving. If you're using it for 7, 8 months, it is understanding your persona and it is giving you a better output. And nowadays, with ChatGPT 4 plus subscription, you have something like a custom instruction wherein if you put that, it is going to give you the answers accordingly. Okay, now I can back. So now coming to this. So this is basic generative AI. I'm not going to the technical definition, but this is what generative AI is, and we have the control over the output, and that is why it is so essential that we all can use it. Now coming to this hype cycle, then this is what I was telling earlier. In 2016, it was blockchain. This is from Gartner research, and 2016, everyone was talking about blockchain. 17 IoT platforms, deep learning, people were talking about, and this is the peak of the hype cycle, and these are the things that have happened. Digital twin. Many of us have heard about the word digital twin, and I remember in all the in GITEX and everyone was talking about digital twin. Then we had our NFTs, the AI augmented softwares. Then we had something related embedded AI, 5G in 2019, and then 2022 it was Web3. I remember in GITEX last year there was nothing about AI. It was all about Web3, blockchain, and all those things. And it's 2023. How many of you have visited GITEX this year? So I'm sure the theme of JATIS this year was AI. Everywhere there was AI powered, all the posts were centered around AI. And right now, generative AI, when we say AI, everyone is talking about the generative AI boom. Every company is using this. They are powering this for whatever customer experience that they are using. They are using generative AI in all the departments of that. So as I mentioned by the report, right now generative AI is at the peak, and every company is now investing a lot of money in this particular area that is there. And now about this, how can you use it, right? So this is a roadmap for the businesses, right? If any business comes and asks like how to use generative AI, for individuals it is different, but for businesses it is very important that they have to understand what is their current data strategy. So some companies reach out to me and they want to have a generative AI, they want to implement something, but when I go back and see that they don't have a reporting system in place, they don't have a proper data strategy in place, and if you don't have a proper data strategy, if you don't have security around data governance, generative AI cannot be implemented immediately. You need to first make sure that your data strategy is fine, your reporting is fine, because these generative AI tools are not open AI API calls. You need to also use retrieval augmented, or basically you need to use your local data that is there as knowledge. So we have to align our organizational strategy with the AI and data strategy, and then we need to establish responsible AI guiding principle, because this is very, very important before you go in any project, because we are using customer data. We are using, if there is any breach of the customer data with the OpenAI API calls and the security concern, it is not only going to hamper your company's image, it is going to be security risk, business risk, and these things are very important. Then many of the talks you might have heard about responsible AI, and these things take care of. Assess your maturity, as I was telling, where the company is correct right now and where you can go in the next 6 months. Before you plan the projects, the first step is there are a list of 10 projects that you really want to do. You make a 2 by 2 matrix, business value and complexity, which is more having more business value and less complexity, go for it and accordingly plan it. So this is very, very important for any company who wants to do something in generative AI space. You need to first have a proper roadmap, and this is not just going to happen within weeks. You need to have a plan for a year or something. Now coming to generative AI responses, and this was I also presented last time about how a company can start using generative AI. The first thing is prompt engineering. I'll talk more in details about it. This is, you don't have any local data, you're just using an OpenAI API call and doing some prompt template and doing some instructions to get you an answer. And many problems are solved by this particular thing. Then we have retrieval augmented, where we are using, I need to use flow. Yeah, where we are using local data for knowledge and the OpenAI LLM for the inferencing and the for the logical reasoning of what you are actually asking. Then we have fine tuning, where we are doing continuous learning. to make the model better, to make it optimal and all those things. And if that does not happen, build your own LLM. That is the last step. And when I say that everything has to be used together, and this is how we get sure in the generative AI space in our company. We should always start from the first and do go step by step and see what is solving a business problem. And now coming, this is the main part of this particular talk, the why generative AI is so much used, the application landscape, because a lot of applications are being built because of generative AI. This is a very basic landscape. This is from AWS research as well. So the text, you can see there are mainly text, code, image, speech, video, 3D, and other. And these are the different type of applications. I will not go through each one of them, but you can see in text there are so many use cases in code, in images, and all these parts. And why this is important? Because in every area there is a lot of opportunity. And these are some of the startup examples that you can see, that is the companies that are doing text to text. You can see all these companies, and all these apps have been powered by generative AI. And these are just some of them that we have listed from a research report, text to text, text to code. And have a look at these images. In the next slide, we will talk about it more. Text to audio, text to 3D, and text to video. For every use case, there are a lot of applications already, and it is going more and more. And why this is important, and I'm going to talk about application development. This is very close to me. 10 years back, when we used to build machine learning models, it used to take 1 year to do a project end to end, because there was no LLM, no generative AI for labeling the data. One example, if I give you, we did a sentiment analysis for Best Buy and Accenture. When I was in Accenture Consulting, it was a sentiment analysis for customer reviews for different products in Best Buy. So we needed to label a lot of data. It's a very simple use case. What are the reviews? Is it positive, negative, neutral? But we needed to, there was NLP, there was technologies, but we needed to do some annotations. We needed to make sure that the annotations are proper, and it took time in labeling the data, then training the model, and after we built the model, tested it, the accuracy, we needed to deploy the model. And at that time, we were data scientists. We were not, we were working very closely with the software engineering team, because we did not know the deployment. It was not that accessible for us. And as a big company, there were different teams for different things. And deploying a model is a work. At that time, software engineers used to make sure that whatever application you are doing is getting deployed. And it took a lot of time, 1 year, and to see the effectiveness also took a lot of time. And now the same thing that can be done within 1 week, not even days. If you want to do end-to-end properly, can be done within weeks, to make sure that you are using a prompt-based application and doing an API call, and you can do it very quickly. And this change has really been a big, you can say, a positive news for many of the application developers, that now, even being a data scientist or machine learning engineering, you can build an application and you can deploy it using these technologies. You can use Hugging Face spaces to start with, and use any other deployment that is there. Now, coming to this particular landscape that I wanted to tell about the generative AI, we have the first layer, the hardware. We all know that we have companies like NVIDIA, Intel, AMD who are making the chips. We all know that there is a shortage of the chips that are there for from NVIDIA. There are, because a lot of demand is there from companies to use it, and these are the companies that are one of the backbones. Then we have the infrastructure layer, because we cannot run a generative AI model in our system. We need cloud, because it requires a lot of processing power. And then we have some of the developer tools that can help you doing that. And over this layer, if we can build a lot of applications and use cases. And why I'm telling you this, the previous slides that I told you, the 2 slides, text to text, text to image, so many use cases, so many products that you can build over these technologies. And we all know that companies are coming out with applications every day to solve a particular use case. And this is the push that is generative AI is giving every individual. And that's why I'm focusing on use cases. Every individual here in this room has some use case. They are working in a company, they have some business problem to solve. They can use the infrastructure, developer tool layer, and hardware layer to use generative AI and solve that problem. And use case is very important. Yeah, this particular slide talks about the current situation where there is lot of value, the ads and web search places where Facebook, Google, all the big companies are spending billions of dollars and solving that problem. But the main thing, what I feel the future will be at the low tail, wherein small companies that have rich data, but they don't have an AI and tech team like Google, Facebook. Now they will be able to use generative AI technologies like food inspection. There are companies right now who are doing image-based recognition of the pizzas, whether it is a proper round shape, the ingredients are proper. So they are using these technologies to get that done, wheat harvesting, metal grading. And this is where the power is going to come. Every company that whatever they are doing, they are good at that business. They don't need to care about the technology so much. Don't need to know about AI so much. They can just provide prompts. They don't need to write the code, they just need to provide prompts and they can get solutions. And this is where we feel that the future is going to go. More AI developers are going to help these small companies solve specific problems because here it is already very crowded. A lot of big companies are focusing and we cannot compete with Facebook, Google, and Amazon. So we need to try to help these the tail end to solve these problems with these solutions. Now, how can I use it? Very simple way for building an application, and most of you have heard about custom chat GPT. Anyone there has tried custom chat GPT? Custom chat GPT, the new thing that has launched. So in that OpenAI's documentation and the dev day that happened recently, they have really simplified how to build an custom chat GPT or AI application. Three things are required: instructions, that is your prompts; knowledge, that is the same like our retrieval augmented generation, where you give your files, you upload your files that are there, and the chatbot or the AI application is going to use this. First, the priority will be given to the knowledge to give the answer. If the answer is not there in the knowledge, then it is going to go outside in the Bing, browse through the Bing internet or go and get it from somewhere else. And the last part is actions. Suppose you have the same thing like agents, plugins that we know. Suppose you want to do some office automation, you want to send an email or a tweet to that application. So you can use the Zapier AI to connect it with that and integrate it, and you will have an end-to-end solution. So these are the main three things that are there, and it can get complicated, but these are very simple steps that are there. Now coming to this type of now, prompt engineering, I wanted to quickly talk about because this is one of the steps I talked earlier. There are two sides for prompt engineering. So all of us are users already. We are already using ChatGPT. Everyone told that they are using ChatGPT. How you can become a good user of prompt engineering in ChatGPT, and the second is the developer. While you're developing applications, how you can develop a good application. But to develop a good application as a developer, you should also understand how a user behaves because you are prompting and you are a good user and you have to capture what a user is trying to tell. So this is very linked to each other. And I'm going to talk today about how the user way. The user four things you need to always write in a prompt which will make a prompt complete because ChatGPT is the way it behaves. The more the information you give, the better the response will happen. So you need to always give a role, and you don't need to give a role if you have custom instructions. You can always put that what is your role? You're a data scientist with this much experience, and this is your audience that is there. So, but if you don't have that, you should give your role so that they will give you a particular output that is desired to your persona. Task, what you are asking it to do. Constraints is basically if there is any limitation of words, if you don't want to use any marketing buzzwords, and expectation is the tone, the format, style, and all those things. One simple example, like generally a beginner will writing an article on a particular topic, but if you want to make it detailed with all the four things, so this is one quick example that you can do: the role, the task, the constraints, and the expectation, the style and the formal. is mentioned, and this will help you get a proper output that is very much unique to your own style, and which will also be help in the SEO, because this is an SEO article for my website, so it has to be Google friendly. And all the rules that I have written here are from the Google SEO, the rules that are there for the ranking. So this is the thing that you need to just keep in mind. Four things whenever you are prompting: role, task, constraints, and expectations, and you will get a much better output. Yeah, if you write this, the first one, the output will be very general. Many people will be using the same thing, and it will be very common. And in the plagiarism also it can get tracked. But this one will be very specific. The tone was there. Now challenges, I always talk about the challenges because it is very important to understand that this is very new. Laws are being still made upon this particular thing. Nothing has been finalized. Who is the owner of the data and all those things? If people keep asking, so you need to be aware of the things that are there. Data security, as I mentioned, if you are in a company, if you are using customer data, you have to make sure it is anonymized. Nothing is being shared on OpenAI API, because now the leaks can happen. Any things can happen. Cyber security and all. You have to be sure that everything is proper. That's why I mentioned in the AI strategy, you have to align it with your data strategy as well. And compliances, you should be aware of the compliances. Suppose you have a customer in Europe, you should know about EU Act. There was some news about EU Act. You should at least read about it. If you in Dubai, if you have, you should always see the rule of the country where your customer and the data is, and be aware of it. The accuracy part is also important, interpretability and explainability, because if these models are there, if you have a customer facing model, if you have a wrong output, it is not only going to affect the brand, but it is going to affect the business. So these are very important. And the last is integration with existing workflow. If your company is sitting on AWS or GCP, you have to think about a solution that can be easily integrated. Or think of using generative AI technology that is completely out of the box, because better to have the integration and make sure everything is synced together. So now the three takeaways I wanted to just give. One use case, identify one use that you can start, even personally, because first every one of you here should be personally use these technologies and be comfortable. Then only you can be advocates to your company or to your business to start using it. And then align your company strategy with AI and data strategy. Because as I told you, security, data security, your how you are capturing the data, and where is your model stored? Is it on open source or is it on a closed network? Make sure all these things are answered. And prompt engineering is very important, because we understand coding is changing, search is changing, and everyone is now doing a prompt. And in the near future, prompt engineering is going to be very important. The better you prompt, the better outputs you will get. So that's it. I just told about the community. You guys, if you're not part of it, you can scan it. And now I will introduce Patrick. So Patrick is going to talk about DeepMind. And and what is the format? The format is basically we are going to have a talk, 30 minutes each, and then we will all the three panelists. So the third panelist is here, Mr. Patrick, and he's going to speak, and then all of us are going to take questions and answers. And that is the format. So it is going to be like a panel discussion. You can all of us can quickly introduce yourselves and ask us questions, and then you can take it over. So here I have Patrick. He is the co-founder of the community, and he is very passionate about AI, and he will take it over. He will introduce himself and thank you, Patrick.
Hello again. So yes, as I mentioned before, my name is Patrick Cheeseman. A little bit about me. I've got a master's in AI from a very long time ago, in the 1990s. Back then, the AI science of AI was just beginning. I mean, AI has been around since the 1950s, but the basic principles were taught then, but we didn't have a computing power back then, so we didn't take advantage of what it could do. It's only recently, I was looking at this the other day, in the 1990s, halfway through the noughties, nobody could get funding for AI because it couldn't do anything because it just wasn't a computing power. It was only towards the back end, the start of the 2010s, when computing power started to kick in. And I was explaining to somebody earlier, a lot of it was on the back of computer gamers who were creating more compelling, graphically intensive computer games. So there was a demand to build more powerful graphical cards. And by coincidence, the graphical cards just happened also to be very good at processing neural networks, etc., etc. So we can thank, if you know somebody who plays computer games, you can thank them for the, for the new industry that they helped develop. So I wanted to talk about Google's DeepMind because generative AI is very much in the popularity space at the moment. Everybody's talking about it. But there's a lot of AI companies doing a lot of work behind the scenes. And I actually think DeepMind will have far more impact on our society than anything else that's going on at the moment. And hands up if you've heard of DeepMind. Okay, so there's a couple of 2-3 people, right? So I'll tell you a story about where they came from and what they're up to. It's very powerful stuff. So hopefully, I've got some videos in this presentation as well. So you like my opening slide, by the way? That's in reality. Right. So what is DeepMind? It's a company started in 2010 in the UK. They're based in London still. They're by Michael Dennis Hassabis. Dennis Hassabis is a child prodigy. He was a chess champion at 11, 12. He was #2 ranked in the UK. He was an absolute genius. He started writing computer programs on the computer when he was 6 or 7, 8 years old. He was a games programmer before he was at school. He was writing games for other companies whilst he was at school. He finished his schooling 2 years earlier than most people, went to university, got a double first at Cambridge, did a PhD, was working at MIT, lots of places, because he was really fascinated by AI intelligence. He went in about 2009, while thinking about intelligence and AI, he realized if you had a better understanding of the mind, you would have a better understanding of how perhaps we could get to the goal of general intelligence. So he went to UCL London, did a master's in neuroscience, and he met a couple of other gentlemen there, which, as a result of that, formed DeepMind in the UK in 2010. What is the vision for DeepMind? Well, back then it was to build AI responsibly, but to benefit humanity, to transform the society, and the chief goal is artificial general intelligence. This means an intelligence that could look at any problem and solve it, okay, without any programming or intervention from the human being. So the most complex problems that are in society today, energy, waste, climate, health, there's so many things that need to be tackled to work more effectively. That's what they started to try to do. In 2014, because they were hemorrhaging so much cash, they negotiated with Facebook and Google. Google won the auction, and they bought them for £400 million. But the other advantage was they now had access to all of Google's data resources and their expertise as well. That really started to transform what they could do. So what is artificial general intelligence? Well, here's a list. Human-like cognition, the ability to perform intellectual tasks that a human being can do, such as reasoning, problem solving, learning perception, and natural language processing. Generalization, the ability to apply knowledge and skills learned from one domain and apply it to solve problems in another domain without any more fine-tuning or programmatic. So you should be able to understand something with a completely different domain and solve that problem as well without any more programming of those programmers. Self-understanding, the ability to plan and reflect on one's own goals, beliefs, and actions. Autonomy, exactly, must be independent from the programmers at the moment. And sentience, the ability to perhaps experience subjective feelings and emotions and to have a sense of self and consciousness. Because perhaps that's an important part of who we are, and how we solve problems as well. This is the first of the videos. So it's a 5-minute video introducing to the company and explain it far better than I ever could. So we're going to watch the video.
Has created all of modern civilization in a way that shows how intelligence and how broad it can be used. Our mission is solving intelligence to advance science and benefit humanity. Real research needs doing like that. We try to create this unique environment that is geared completely towards using artificial intelligence for advanced innovation. We are embarking on what will turn out to be the greatest adventure in human scientific history. When we started DeepMind, we looked at machine learning and neuroscience, and it was a good chance that this was going to open up the possibility for artificial intelligence. Our goal is to have an algorithm that we are looking at and like that.
And now I'm doing research and for development API.
The new system which will be holding the task of usually
We're merging that between the reality. Parts of the comments that we had are the next time we should be on the
What's going on with you? Maybe I really feel like this is really what the chocolate factory. The piece of work is to use games and simulations as a perfect proving ground for developing AI.
They started working on their just and play card games and actually learning more complex behaviors really quickly.
We're going up the game level and actually tackling more complex challenges.
What is the computer program that tests against one of the brightest minds in the world and why?
Stories just pieces like they have just that. The real players are working on games, but we're always one step on the way to making more general systems.
So much we don't know, but how do we start thinking about the downstream impact of our research? How do we pioneer responsibly?
As an organization, we take that job extremely seriously, but doing rigorous research and efforts. We actually have an opportunity to really think and say, what could AI do for society in a positive way?
New projects, the more people who are using these algorithms of AI, the greater the impact we're going to have on trying to stop climate change.
We already use them in many things. For example, probably having vision accidents and actually predicting weather patterns.
48 degrees is clear in London.
We're generating realistic sounding voice for visual systems without wavelength systems.
How are you?
With the research that's been doing, the exploration aspect is really important because we're tackling some of the hardest problems in the world. Our biggest scientific breakthrough today has been post technology. We use AI to solve a 50-year-old lab challenge problem, which then enabled us to release the structure of organ proteins. The implications are immense from better understanding how the humans progress, how we can discover drugs, etc. The best inventions in the future are going to come from disciplines being combined. So what that requires then is more resource like thinking.
To build artificial intelligence, we need creative thinkers that can come up with something that nobody has thought of yet.
You have to think, you wouldn't recognize the difference between art and science. This is the joy of that, I think. And if we can find those science and inspiration, find them to problems that are important to human health, that would be transformative for the business. I think this is the most important piece of the education. Great environment, and it's something for whether they work or whether they don't work. The more you fail, the more you learn from them. I encourage people to feel as fast as possible. Systematically, what you might be learning that systematically won't different. The work here is hard, but it will be worth it if we manage to make it possible. If we do achieve this, it's an incredible level. Everything we do here is celebration of mind and knowledge. We're not trying to go with a big inspiration from the brilliant voice consciousness, voice feeling, or voice creativity. Those kinds of questions I think we're going to be able to try and answer some. We learn one thing is that we're very bad judges of the possible. That mission is to understand as much of the world as we can. We solve intelligence. AI, I think, is the most fantastic possible tool we can have to help with that mission. We want to do the next thing that that means to find something that a lot of people think is too hard. And we're just going to have to go ahead.
that was an essay. Like 7 years old. What exactly are they doing? Well, so what exactly are they doing? They're using neural networks. As I explained at the beginning, Dennis went back to university to understand the brain works, because he realized that the only possible way forward to try to get any kind of general intelligence is to understand how human brain works, or animal brain works, because we can do it. So by helping to understand patterns and using different types of learning, reinforcement learning, supervised learning, etc., we can build hopefully a set of genetic general algorithms that can learn different scenarios and be applied to other scenarios. In a neural network, you have inputs and you have outputs. You put your data in one end and you have a series of layers. And in those layers, you assign different weights and depending on the problem you're looking to do. You're trying to find patterns in data. Patterns are what you see wherever the data comes from. I'm going to run a second video here explaining a little bit more detail about neural networks work, because they can do it a lot better than I can.
Construct a neural network that differentiates between square, circle, and triangle. Neural networks are made up of layers of neurons. These neurons are the core processing units of the network. First, we have the input layer, which receives the input. The output layer predicts our final output. In between exist the hidden layers, which perform most of the computations required by our network. Here's an image of a circle. This image is composed of 28 by 28 pixels, which make up for 784 pixels. Each pixel is fed as input to each neuron of the first layer. Neurons of one layer are connected to neurons of the next layer through channels. Each of these channels is assigned a numerical value, known as weight. The inputs are multiplied to the corresponding weights, and their sum is sent as input to the neurons in the hidden layer. Each of these neurons is associated with a numerical value called the bias, which is then added to the input sum. This value is then passed through a threshold function called the activation function. The result of the activation function determines if the particular neuron will get activated or not. An activated neuron transmits data to the neurons of the next layer over the channels. In this manner, the data is propagated through the network. This is called forward propagation. In the output layer, the neuron with the highest value fires and determines the output. The values are basically a probability. For example, here, our neuron associated with square has the highest probability. Hence, that's the output predicted by the neural network. Of course, just by a look at it, we know our neural network has made a wrong prediction. But how does the network figure this out? Note that our network is yet to be trained. During this training process, along with the input, our network also has the output fed to it. The predicted output is compared against the actual output to realize the error in prediction. The magnitude of the error indicates how wrong we are, and the sign suggests if our predicted values are higher or lower than expected. The arrows here give an indication of the direction and magnitude of change to reduce the error. This information is then transferred backward through our network. This is known as back propagation. Now, based on this information, the weights are adjusted. This cycle of forward propagation and back propagation is iteratively performed with multiple inputs. This process continues until our weights are assigned such that the network can predict the shapes correctly in most of the cases. This brings our training process to an end.
So on this video is a very simplistic understanding what a neural net does. All I want you to take away is that it's recognizing the stream of data from pattern, using these layers, depending on the weights and the bias and the activation function. In the first situation, you saw it got it wrong. It knows what the result should have been because it's an example of supervised training. So it calculates an error margin and passes that back propagation to adjust these parameters, and we'll repeat that cycle many times till it gets it right. And then once it's understood what the weights and biases should be, you should be able to throw another shape at it, and it will immediately say no or yes. And over time, it will learn, for example, being trained by an outside third party. That's the very simplistic view. Now imagine billions of these scaled up on massive clusters of AOB and Intel graphics cards. This what is required today to try and solve the problems using far more complex versions of this model. In the learning that we're seeing, there are three types: supervised. Supervised learning is you know what the result should be, and you provide feedback until it's trained to recognize the right result. Like the example we just saw. Unsupervised learning, where you give it data, but you don't tell it anything about what's right or wrong. It has to understand the data itself and understand what's right or wrong. And in reinforcement learning, you don't give it any data at all. You just ask it to look at a problem and by trial and error work out what the problem is and how to solve it. DeepMind uses all three of these. When it's trying to solve a new problem, it starts here. It knows where it wants to go, and it trains some simple versions of models to get to the point where that works. Then it gives it data that it hasn't told what the output should be, and then it lets it out into the open to look at the problem without any input from the user as well. This is the model that they use in DeepMind, and they found it to be very, very successful over time as the models get more and more complex. The very first thing they tried was Pong. Now, I'm old enough to remember playing this game in the 1970s on an Atari system. If you ever heard of Atari, it doesn't exist anymore. But we had a computer, a TV, and a panel, and you played it. And the way it works, it's very easy. You can show you all about Pong. The panels go up and down, four times, and you manage to cross the line and score. That goes up, and of course, the opposition, the score will go up if they manage to get the ball past you. So in this sense, Pong is the agent. The agent has to make a decision. Do you move the panel up or down? That changes what's in the environment. If it's ultimately you score points, then you get a reward. If you lose a point, you get a punishment. And so if you're training something to solve a problem, you have to give it a reward function. The reward function here, this is why they started on training on games, because games normally have win or lose situations. Very obvious how to play a game. It started on the most simple game they could find, Pong. Trained it, they ran hundreds of thousands of iterations of the game. They were running it overnight. There were little computers on their phone coming the following morning, and they would see the results and it's working. And then they would never be doing it themselves. Multiple hundreds of thousands of iterations. It became a perfect Pong code. Any human, absolutely nobody could beat it. What's happening is, this is a screenshot made of a pixel on the computer. Each pixel is sucked into the neural network as a pattern. Then using the mechanism I was explaining before in the video, you have a probability of whether should you move a panel up or should you move a panel down. In the supervised version of the game, obviously it knows you tell it the scenario you want it to be, so it learns from your external training. But in the independent version of it, the only thing it will know is it has to get the top score. That's the only thing you tell it. All it's doing is looking. You feed in the first pattern, you decide, do you want to go up? Feed in the next pattern. If the game's iterated, next. You might get second later in the game, you feed it again, you feed it again, you feed it again. And eventually you're either going to lose a point or you're going to gain a point. You then run that hundreds of thousands of times, as I say, prove it, and it learns purely from trial and error which way of how to go in the sequence of events. As you can see here, up, down, down, up is a win. When you're down, up, down, lots of lose, lots of loss, etc., etc. So it's going, and you imagine it's going through these very, very quickly to achieve which is the win, which is the loss. Now, is what I call the credit assignment problem. Up, down, down could be perfectly valid moves. The final one could have been a mistake. So how do you, this is what the credit, where do you credit the final result? Was a mistake on the peer or was it a mistake further down the chain? They use a concept called policy gradients, which is a technical term for training the neural network to understand the ability to pick where in that chain was the mistake made, and they'll be able to then inform a neural network, inform the system about over time that was the best strategy to make. I mean, if you multiply that out millions of times over time, it will then be optimized for the best strategies in these scenarios. At the start of the problem, then it moves to breakout. You have lots of fun with that. Breakout is you have a panel and the ball bouncing up and down, and you have to remove all these pixels. And the funny thing was, the game did better than the human. It learned a strategy where you break the wall in the corner and just let it bounce up and hit back to the wall. It was better than the human did. So when they were running this game, the developers in Google in DeepMind realized that it's all about how the best strategy to make it. And this game was Space Invaders. You'll see examples in some of the other videos how they would run it for 100 simulations and it would play very well. They would leave it up running overnight, come in the morning after 5 panels of installations, and it would be an expert Space Invader. Yes, of course, the classic game. Back in the 1990s, early 2000s, IBM's computer it beat Gary Kasparov, the world chess champion, for the first time, the computer beaten. And it was beaten using a program developed specifically to play chess. DeepMind doesn't know any of the rules for playing chess. All it did was watch thousands and thousands and thousands of games of chess. And the only thing it was told is you have to get checkmate or the other team has been done. And it played it for thousands and thousands of installations and became an expert chess. Okay? It wasn't from generic algorithms, from general algorithms that it had. Then there was Go. Go is probably the most complex board game in history. More variations of playing the Go than all the atoms in the universe. I mean, it's trillions and trillions and trillions of variations. But they took the algorithms they done from chess, changed them to take into account the new game, and they built the European world champion at Go for the first time in history of computing, but from generic algorithms, not from the thing that was pre-programmed to play Go. All it did was watch games of Go, learn how it worked, and then started playing people, and eventually it started winning consistently every time. You know, from a generic algorithm. It wasn't really taught how to play it. This is the power. And as you saw in the video, I started getting a bit more sophisticated computer games. I don't know if it was play StarCraft. So it learned how to play StarCraft by watching other games and then you start to see the power of this approach. So what's it all for? Okay, so I'm going to wrap up this presentation. I'm going to go through 3 different examples of things that people are working on. The first one is mentioned in the video. How long it takes 10 years for a company to spot an opportunity for creating a drug before it's released to the public. Because there's a lot of analysis, safety checks, etc. Part of the problem is understanding how the bodies work. So we are all made up of proteins, which are tiny molecular cells. So they're the building blocks of life. Proteins are created from amino acids, okay? And the structure of a protein is determined by the order and the combination of amino acids. There was a huge problem in medicine about how to predict on the amino acids that you had what the structure and orientation of the protein would be. So it's a 3D model of the protein, you know? So depending on which amino acids and which combination, how do you predict it? And the point is, it would take one PhD student a whole PhD just to understand one protein. Google DeepMind used their algorithms, analyzed it, entered took part in the grand scientific challenge known as the protein folding problem, and after 4 years told that every protein in the human body has now been mapped out by Google DeepMind. It has had dramatic effects because they have released this for open, free use, open source. So they're now, I saw about 500,000 biologists around the world using this data to create new medicines. So, for example, there are diseases now you all know about, what do you call it? When the virus starts to behave. Exactly. So, a lot of thinking, people think it's the proteins that are somehow getting entangled. So if you know what the proteins should look like, and you're seeing the proteins as they are, and you can design a medicine to untangle the protein, you can possibly cure diseases. If that work is going on now, they solved this problem, I think in 2020. They're now working on medicine out of diseases. So right now, in their offices around the world, they're working with biologists, essentially trying to see if you can model a disease. Another example, using alpha-zero and alpha-cube optimizing computers, designing better computer chips. They came up with a neural network to design computer chips, and had a competition this year. They found the best solution 82% of the time compared to people designing computer chips from scratch to solve a particular problem. That will have dramatic effects. Okay, and you can design the chips using this generic algorithm. You can speed up the process, reduce the cost, and get the technology up in a much quicker way. Google data centers, the techniques used were able to recognize patterns and tasks that the data centers perform, and he managed to reduce the proportion of underused hardware by 19%. Doesn't sound a lot, but Google has data centers all over the world, and a 19% increase in productivity will have a dramatic effect on their bottom line. Using the same kind of technology. YouTube. Every YouTube video has been optimized by Google DeepMind's technology. So, okay, reduce the bit rate by 4%. Doesn't sound very much, but once again, how many videos are YouTube chucking out every day? You know, it's in billions. 4% has a dramatic effect on how, you know, once again, utilization of data centers and all the hardware to do that. So you're already using DeepMind's technology. I'll give you an example from the top of my head, two more. One, if you're a computer scientist, you'll know about sorting algorithms and hashing. Yeah? DeepMind analyzed those algorithms. They haven't been improved on for 10 years. Yeah? They improved them dramatically and uploaded them for free. So if you're programming in C, C++, and using the libraries for these things, DeepMind updated them and everybody can now use them for free. Who knows how dramatic an effect? That's very difficult to measure, you know, how that might, the benefit is. There's obviously benefits. And the final example is teaching robots how to manipulate objects. We know that objects are very specialist for journalists. Typically, you train a model for each task, robot and environment, specifically to solve a specific problem. But with the Google DeepMind algorithms, they were able to produce a data set. They got 20 institutions to gather data from 22 robot embodiments, demonstrating more than 500 skills and 150 tasks. And they use that model to train new robots' behavior, and they made a 50% increase in improvement on average across very different economies. So by using a general model rather than trying to focus specifically on the task, it drastically improve how long it took to settle that up and get the possibility. There are a multitude of other examples. I highly recommend, if you're interested, go to YouTube, search for DeepMind, there's a whole YouTube channel. They've got award-winning documentaries about how they're looking out for and the stuff they're working on right now. It's a really game changer, but nobody knows about it. It's really, really interesting. So that's what I wanted to highlight today. I think this is the company to watch for to help them solve the world's problems. Their goal is artificial general intelligence. Okay? So it could, I believe myself, I'm hoping to see that this potentially could drive one of the greatest transformations.